Okay, let's go ahead and start looking at simplifying some radicals when we've got variables involved. So we have our perfect squared list, right? We have, the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. The square root of 16. So we have our numerical perfect square list. I want us to make another list. So maybe on the side of your perfect square cheat sheet, okay? Maybe off to the side, you can write this list. And this is a variable perfect square list. And let's see if we can find something, a rule maybe that's happening. So if I have the square root of x squared, that's just x, okay? Do you remember whenever we said, when I was referring to the radical as an exponent, okay? And when it was an exponent, right, it would look like this, 1/2. Well, what's 1/2 of 2? Just 1, okay? So x to the first. So the square root of x squared is just x. Well, what about the square root of x to the fourth? Okay, well, remember when we wrote the radical as a fractional exponent, what's half of 4? X squared. Okay, so the square root of x to the fourth is x squared. What do you think the square root of x to the sixth is going to be? Well, I'm not going to rewrite it, but as an exponent, you can see that we're just taking half of 6, which is x to the third. What about the square root of x to the 8th? Well, what's half of 8? Half of 8 is x to the fourth. So simplifying a variable expression, okay, when there are even powered exponents are pretty simple. So they're saying if you're given this radical to simplify, and it's the square root of a to the m, if m is a multiple of 2, in other words, if m is even, okay, the rule is you just have a and divide that m by 2, okay? So if I had a to the, or x to the fourth, I just divided 4 divided by 2 is 2. X to the sixth, 6 divided by 2 is 3. X to the eighth, 8 divided by 2 is 4, okay? So you see how we do that? Now, what if you have, so these are perfect squares. What if you had an odd number? Well, it's going to be the same as when we simplified an expression that wasn't a perfect square. What did we try and do? Like when I tried to simplify the square root of 24, what did we try and do? We tried to factor out a perfect square, right? And write it as 4 times 6. What I did was I rewrote it so that I took a perfect square out, 4, okay? That's the same thing we're going to do here. We're going to break it apart. We're going to factor out something that is perfect, and we're going to factor out that even powered variable. And so we'll see how that's done here. So here's some examples. Let's simplify the square root of x squared. This one's easy. Half of 2 is just 1, so it's just x. Okay? The square root of m to the 6th. 6 is an even power. So all I have to do is what's half of 6? M to the third, okay, m to the third. Now, radicals, remember, they're the same as exponents. So whenever you had an expression raised to an exponent, you get to take that exponent to each factor inside of your term. So that's the same here. I'm going to have the square root of 9 times the square root of k squared, okay? It's not really necessary that you write that step there, but that's what's happening. I'm breaking it apart, okay? So the square root of 9 is 3. The square root of k squared is k. Okay, and now I'm simplified. I'm going to leave number 4 for you guys to do. Let's do number 10, or number 5. The square root of 100 is 10. The square root of x squared is x, and the square root of y squared is y. Okay, you see how I got away with not writing, me breaking apart that? You don't have to always break that if you don't want to. I'm going to let you do number 6. Okay, do number 6. Okay, now we're going to see some odd powered exponents. So y to the 5th. Y to the 5th is not a perfect square, okay, because it's an odd there's an odd number of factors of y. Okay, so a 9 perfect square was only even powers. So this is what I need to do. I need to rewrite y to the 5th. Okay, I need to factor out the largest perfect square. So what am I going to do? I'm going to rewrite y to the 5th. I'm going to say y to the 4th times y. Okay, what did I do? I factored out the largest possible perfect square, which was y to the 4th. Okay, what are some perfect squares? Y to the 2nd, y to the 4th, y to the 6th, y to the 8th, anything that's even. So now I can break it apart that I have y to the 4th times the square root of y. Square root of y to the 4th is just y squared, right? And I don't know what the square root of y is. So he stays in there, okay? So what about 8? Well, I have the square root of a squared, the square root of b cubed. That's not perfect. Here, let me actually rewrite this. So let's first factor out some perfect. So I have a squared. How can I factor out a perfect square from b cubed? Well, it's just going to be b squared times b. It's always just going to be one less. That's going to be the largest perfect square. So here I have the square root of a squared, the square root of b squared, and the square root of b. I know the square root of a squared is a, the square root of b squared is b. I don't know what the square root of b is. So he has to stay underneath your radical. Okay. Let's do number 9. Number 9, I'm gonna look and see which ones are perfect. And if they're not perfect, I'm gonna try and factor them out. X squared's fine how he is. Y cubed, that's not perfect. I need y squared times y. And then z to the 4th, that's perfect. So I'm gonna take one step to make sure I factor all of my imperfect squares, okay? So now I can split it. I have x squared times the square root of y squared times the square root of y times the square root of z to the 4th. Square root of x squared is x, square root of y squared is y. I don't know what the square root of y is. And then the square root of z to the 4th is z squared. Now, when you have a term, it is customary to communicate the radical at the very end. And the reason I do that is because maybe we get sloppy and we just write it really quickly. I don't really know, is that z squared still underneath your radical or is it not? I don't know. So what I always want to do is if I have an expression with a radical, I always want to make sure that factor is the last one. So I would say x, y, z squared times the square root of y. That's how I would express this. Like I said, it's just a communication. I don't want to accidentally confuse you. Like, is that radical extending over the z or is it not? I don't know. So to alleviate that confusion, we always just put the radical at the end. Okay. All right, 10. 144, I believe that's on my perfect square list, right? The square root of 144 is 12, okay? So first what I'm gonna do though, before I try and simplify any of those radicals, I'd like to be systematic about this. So my very first step, I look at anything that's not perfect and I try and factor out the largest perfect squares. So my k to the 3rd is not perfect, so I'm gonna say k squared times k, okay? So now I'm going to break it apart. 144, the square root of that is 12. Square root of k squared is k. I don't know what the square root of k is, so he has to stay, he's got to stay inside. Okay. Number 11, I'm going to first break apart anything that's not perfect. 81's perfect, so that's good. R to the 7th, that's not perfect because 7 is odd. So I'm gonna say R to the 6th times R, and then S to the 4th, he's perfect, that's fine. So now I'm gonna split it, square root of 81, square root of R to the 6th, square root of R, square root of S to the 4th. So the square root of 81 is 9, square root of R to the 6th is R to the 3rd. I'm gonna go ahead and write this one next. The square root of S to the 4th is S squared. And then I'm going to save this imperfect guy for the end. We stick them at the end. Okay, I'm going to leave number 12 for you guys to do. Okay, so with some of these guys, we're gonna start seeing some of our coefficients also not being perfect squares. So remember, you have to try and factor out the perfect squares, the larger perfect squares. So 8 is not perfect. Nothing times it, nothing, no whole number, there's not a whole number times itself, that will give you 8. But I can rewrite 8 as 4 times 2. X to the 6, that is perfect. So my first step, I always want to try and if something's not perfect, factor out something that's perfect. Write it as a multiplication problem. So now I can break it apart, the square root of 4 times the square root of 2 times the square root of x to the 6. Now let's go ahead and simplify all of the perfect squares. Well, the square root of 4 is 2. The square root of x to the 6 is x to the 3rd. The square root of 2 is not perfect, so he'll stay inside of the radical. And I'll always put that radical at the end. Okay? All right. I'm going to leave this guy for you. Remember, 50 can be written as 25 times 2. Okay? That's your perfect. All right. Number 15. I got 68 times p cubed. Now 68 I know is not perfect. So if I think to myself, what can I divide 68 by? I might start looking down my perfect square list and start at 36. Can 68 be divided by 36? No. Can 68 be divided by 25? No. How about 16? Nope. 68 divided by 9? No. What about 68 divided by 4? Yeah, 68 divided by 4 is 17. So when you have a larger number that you know is not perfect, but you're not sure if you can factor out something that's perfect, take your number and start dividing it by larger perfect squares and work your way down. So I figured out that 68 is divisible by the perfect square of 4. 4 times 17 gives me 68. Now p cubed is also not perfect, so I'll write that as p squared times p. Okay, so all I did at this step was take each part of my radicand and factor out perfect squares. So I factored out a perfect square of 4 and p squared. So I'm going to split it up. Square root of 4, square root of 17, square root of p squared, square root of p. Let's simplify our perfect squares. Square root of 4 is 2. The square root of p squared is p. Now 17 and p aren't perfect, so I'm going to stick them back inside of the same radical. Okay, we won't ever have 2 radicals in one expression. That would just be silly, right? So we have 2p times the square root of 17p. Okay, all right, 16. 16, 45 is not perfect, and n to the 11th is not perfect. So I'm going to try and see what I can divide evenly into what perfect square I can divide evenly. And I believe that 9 times 5 is 45, right? 9 times 5 is 45. And then n to the 11th isn't perfect, so I'll say n to the 10th times n. Okay, now you notice n to the 10th times n is the same thing as n to the 11th, guys. Remember, when you're multiplying with like bases, you add those exponents. 10 plus 1 is 11. So just so that you know what I'm doing, I'm breaking it apart, okay? Well, I'm going to split it. Square root of 9 times the square root of 5 times the square root of n to the 10th times the square root of n. Simplify the perfect squares. The square root of 9 is 3. The square root of n to the 10th is n to the 5th. The square root of 5 and the square root of n are not perfect, so I'll stick them back inside the same radical. Okay, so I have 3n to the 5th times the square root of 5n. All right, I am going to leave number 17, actually, yeah, I'm going to leave number 17 and 18 for you guys to do. To do number 17 and 18. And maybe I'll work out a couple more to make sure that we're understanding it all. So 160 a cubed b to the 6th. 160 is not perfect, but I'm going to think about what could I possibly divide into 160. Half of 160 is about 80. In fact, it's actually 80. I know 160 is not going to be divisible by 80. Is 160 divisible by 49? No. Is 160 divisible by 36? No. Is 160 divisible by 25? I know no for sure. What about 16? Yeah, 160 divided by 16 is 10. So just take your calculator, start trying to divide larger perfect squares into there. So I'm going to factor out a perfect square of 16. Here, a cubed, I'll write as a squared a, and then b to the 6th, that's perfect already. So I'll split it up, square root of 16, square root of 10, square root of a squared, square root of a, square root of b to the 6th, b to the 6th. And now I'll start simplifying the perfect squares. So 16 is perfect, so the square root of 16 is 4. A squared is perfect, it's a. B to the 6th is b to the 3rd. Now the square root of 10 and the square root of a are not perfect, so they'll go into the radical 10 as 10a. Okay, so we'll start again. Here, 108 is not perfect, okay? But I probably can divide them. I know I can at least divide them by 4. Let's see, 108, can I divide that by 16? Nope. 108 divided by 36. Yeah, 108 divided by 36 is 3. So you want to pick the biggest one. So 36 times 3 is the same thing as 108. R to the 18th is still just going to be R to the 18th because that's perfect. Now, S to the 13th is the same thing as saying S to the 12th times S. So I'll write that with an even power, okay? So I'll split it. Square root of 36, square root of 3, square root of R to the 18th, square root of S to the 12th, square root of S. So I got 6, square root of 36 is 6. The square root of R to the 18th is R to the 9th. The square root of S to the 12th is S to the 6th. And then my square root of 3 and my square root of S is not perfect. So I'll go ahead and write those inside of my radical. Okay? All right, I am going to leave the last 4 for you guys to do.